Hey everyone, welcome back to the Microwave Lab. Today we're going to be doing a little bit of troubleshooting on this Ranger 696 radio. It's an old school radio from a Radiohead friend of ours, and he gave it to me to take a look at and see if I can figure out why it's not transmitting. Everything else seems to be working okay, it's receiving fine, and so I poked around a little bit, checked all the power transistors, nothing shorted, nothing behaving weird there. Just checked them with a multimeter. Nothing fancy, but nothing inside the radio looked like it let smoke out or anything like that. So it's on to the next tier of diagnoses. I'm looking at the audio amplifier chip here, which is this Toshiba TA7222AP. And what I did was I went online and I found the pinout. I found the let's see, where's the data sheets here. Pinout and all the info on here, and sort of cross-checked this with an example schematic I found online for this is for a just a general purpose audio amplifier. This somebody put together, so we're gonna build this schematic to test this audio chip. Now I poked around on this with the multimeter a little bit. Nothing was shorted, nothing was really behaving weird, but it's not like a discrete single transistor where you can check like a 3-pin transistor, or if it's a BJT, you can check the diode, how it's diode connected, or the diodes internally anyway, or check a MOSFET to see if it's shorted or if anything's weird is going on. So we're going to build this example circuit and hopefully just run some audio frequencies through it and see if it works. And if not, then we'll go ahead and order a new one. So I was all ready to order a new one of these just on a whim. Just because it was the most complicated part that I couldn't really test, and everything else seemed okay. So, but I figured this would be a fun little project to share with you guys, and we'll get the circuit all built. It's nothing too fancy, just some passives and a speaker and an audio input. So we'll just use the function generator for that, and so we'll get it built, and I'll get back when I'm done with that. Okay, so I finished up building the circuit over here. I took a few liberties on the component values. So here, this 470 microfarad cap on the input is most likely just it's just a nice big bank of electrons. So that the input has for a big booming bass or something along those lines. So I used a 10 microfarad for that. That's not a critical component. And here on the signal path, we've got the input here, and I don't have a 100K pot, so I used a 5K, which sounds like this is a nice trim pot. It sounds like it's a long way off, but this is just to limit the input for volume control, and I have complete control of the input. We'll be using a function generator. 4.7 microfarad. The orientation on this is a little bit weird. It's positive towards the circuit. Yeah, I don't, maybe because of the ground. Yeah, that's most likely why. But I didn't have a 4.7 microfarad, so I used two 10 microfarads in series, because that will split or divide the capacitance by 2, and I checked it with the fluke, and we got 6 microfarads, so that's good enough. 27K resistor, I used a 22K and a 5K, just soldered them together. Over here, 220 ohm. I used 210 ohm in series, and then 47 microfarad cap I had, I believe. Yeah, there's the cap. There's the 210 ohms. Pin 7 and 8 are grounded. That was easy. And then pin 9, this capacitor threw me off a little bit because pin 9 is the output of the amplifier, and so this small capacitor is most likely to give high frequency noise a path to ground. Because higher frequencies see capacitors as a lower impedance, so a very high frequency, if we got some noise or something, will get dumped to ground, but audio frequencies, yeah, it should ignore that capacitor. And then pin 10 is a little bit of a mystery. It says in the schematic, or the data sheet, if I bring that up here, pin 10, bootstrap. I haven't a clue what that means, but and there are a few other unused pins. There's a mute function and a few other things. So I don't know what a bootstrap is, but we've got a 47 microfarad connected to pin 9, which is the output, and I'm using it looks like here on the schematic it's an electrolytic we can tell by the polarity symbol, but I'm using a polyfilm cap. It should work just fine. Nothing crazy going on, and it's fine on the voltage. And we've got a big 470 microfarad on the output, and I'm not really sure what that's for. This input capacitor, probably not too critical, just because that's most likely for AC coupling. This one on the output, I guess it's to AC couple the output, and I'm not really sure why it's so big. Probably just for low I guess that makes sense that we've got we can dump high frequencies to ground over here, and then send everything else over to the speaker, DC coupled, I guess, just in case there's a failure in here or something. So I'm gonna, and then the speaker I'm using the speaker out of the Ranger radio. I just attached some bodge wires there and ran it over. And this specifies a 4 ohm speaker, and this is an 8 ohm, and just mostly for the reason for that is max power transfer and impedance matching and that sort of thing. But using a higher, in my brief looking around, using a higher impedance speaker isn't a big deal, because it'll draw less current and you won't get the same power output. But it's if you use a lower impedance speaker, you could pull extra current and your components will get hot, and that could cause a problem. So I'm gonna screw around with this for a little while, and we'll see if I can get this audio chip to work. So I was screwing around with the circuit for a little while, and I'll come up to here to the function generator. We'll turn on our low frequency output, and you can see or hear that we've got some output. And I'll just turn we're at 500 hertz right now. I'll turn this up just a little bit. I don't want it to be too annoying or loud, but yeah, it seems to be working. This is 600 hertz, 81 millivolt input. I turned it way down. It was pretty loud earlier. I turned the trim pot down, and that was just like I suspected, just for volume, and it's working. So I'm a little disappointed. I was hoping this chip wouldn't work, so that way I could further my diagnosis. I'm going to turn this off, actually. There we go. I was hoping it wouldn't work, so I could further my diagnosis on this, or just pin it on this, and I could replace the chip. But it looks like it's working, so I guess I'm back to the drawing board a little bit. But anyway, this is less about the troubleshooting the radio and more of just a general troubleshooting technique. Is if you can remove the chip, an amplifier or MOSFET or something from the board, and test it on an external circuit. It's a good way to see if your part is good or bad. And so that's all for now, guys. I hope you learned something. It was fun putting this together, and I guess I'll be back to the drawing board on the troubleshooting. So thanks for watching, and we'll see you in the next video.